Welcome back, ladies and gentlemen. We're now going to look at number 25 from chapter 9, and we'll work through some of the solution. I'll give you mostly the setup, because seeing this situation really is going to help you figure this out. This one is not quite so difficult as number 24 was to get through. So we have an astronaut and a satellite, and let's draw some sort of crude satellite here. Sort of structure, and we'll have some solar panels coming off. There's our satellite. Brilliant. Now, an astronaut. Yay, I'm in outer space. Okie dokie. So, we have some information about these objects. We know that the astronaut's going to push on the satellite, and it's going to give the astronaut will give the satellite a motion, a velocity relative to the shuttle that they traveled up in. And due to the push, let's say we have a velocity this way, and we're told that this velocity of the satellite 0.14 meters per second. We're also told that the mass of the satellite is 1,200 kilograms. Well, for the sake of being consistent, let's give that direction the positive value. But we know what's going to happen. Newton's third law says, well, action-reaction, so astronaut pushes satellite, satellite pushes astronaut. So the astronaut will head this direction. We know that there will be a velocity of the astronaut. We do not know what that is. We do know the mass of the astronaut is 92 kilograms. But what we're asked is how far away is the shuttle if 7.5 seconds after the push, the astronaut bumps into the shuttle or reaches the shuttle. So the shuttle somewhere over here. This is not going to turn out so well. I am definitely not the artiste when it comes to this stuff. So shuttle, I don't know, nose, kind of an airplane-ish shape, sort of a delta wing, big tail, some engines. Okay, and kind of a wing structure. Anyway, you get the idea. Space shuttle. So, the astronaut is going to travel this distance d from this position, and we have a time of 7.5 seconds to get to the space shuttle due to this push-off from the satellite. So there's the initial thing, right? There is the setup and the goal. The goal is how far away is the space shuttle. That's the answer we are looking for. That guy. Okay, so listen. The push-off, right? If you consider the system that we're dealing with to be both astronaut plus satellite. Okay. Then the push is an internal push, right? Remember, that's a big kind of idea that we're dealing with in this chapter. Defining the system, particularly with section 9-4. The system, as defined this way, means that the push from the astronaut is an internal force. It's coming from within the system. Okay, then that means that push does not affect the momentum of the system. So it's an internal force, it's not an external force. There's no external forces acting on our system. There's no net force. And therefore the total momentum of our system will not change. Okay, so there's your big hint, right? It has again to do with conservation of momentum. Where the total momentum does not change from before to after. And since we can look at the total momentum as the sum of all the momenta of the individual objects. So there's a momentum of the satellite, and there's a momentum of the astronaut, right? And this could be before the push, but it must be the same as after the push, and so it must be 0. And I'm going to let you finish that work because I've almost given it away. I want you to keep going, please. And the answer for this one is in the back of the book. Now, depending on how you work through this and how you're thinking about it, you realize, well, to the right is the positive direction, the way I have set this up. And the astronaut is traveling to the left, and so that distance might come out to be a negative answer. If the back of the book gives you a positive answer, that's okay. As long as you can work through this and with a consistent setup justify a negative answer here, you're fine. You're fine. All right, so work this out. Double check your work, your final answer with the one in the back of the book, and you should have no trouble with this one from here on out. Thanks for watching. I'll catch you next time.